Hi, this is Mr. Hendrickson, and this is the Conceptual Physics Counting Sig Fig Rules. During the course of this mini lecture, it would be a good idea to take out a pencil and paper and follow along and jot down a couple notes. You can also find these notes located on the physics website as well. As you begin to take notes and fill in each portion of them, you will end up with 5 sets of rules, each with an example. It will probably end up looking something just like this. Rule number 1, when in a measurement, any non-zero digit is always significant, as well as zeros between non-zero digits. So what that means is that any number that shows up that is not zero was a measured or estimated digit. In addition, any zeros or sandwich zeros found in between are also counted as significant figures. So if you take a look at these two examples here, in the first example, you should quickly notice that there are 1, 2, 3, 4 digits, none of which are zeros. So this measurement here would have 4 significant figures. In our second example, 15.60007, you'll notice that there are 1, 2, 3 numbers that are not zero, and then another number at the end that is not zero. We see that there are 3 sandwich zeros, so in this case, every number within this measurement is considered significant. So it would have 1, 2, 3, 4, 5, 6, 7 significant figures. Please make sure you have this rule and these examples written down in your notes. Rule number 2, any zero to start off a measurement, called leading zeros, are not significant. These numbers are simply placeholders to express the magnitude of a number. So, in this example that you see below, you have a 0 decimal spot 0005. All 4 of these zeros that begin the number are what we call leading zeros. They're simply there to show us that this is not 5, this is not 5 tenths, 5 hundredths, 5 thousandths, this is 5 10,000ths. It's there to express magnitude. In this case, only the 5 was a measured digit, so therefore there is 1 significant figure. Please make sure that you have the rule and example recorded in your notes. Rule number 3, any zero that ends a number to the right of a decimal point is considered to be significant. These zeros are not necessary as placeholders. They are not there to express magnitude, but they are there to actually express measured data. These are measured zeros. If you look at the example below, you have 15.0000. These zeros are not needed to show that this is 15. They are needed, though, to show that this was measured and it is known to be exactly 15 out to the 10,000th spot. So in this case, we would have 2 sig figs from 1 and 5, and then 4 more from these trailing zeros after the decimal point. So in this case, we would have 6 significant figures. Please take a moment, write down the rule and the example below. Rule number 4, any trailing zeros without a decimal point are considered not significant. These zeros are placeholders. You see, with the presence of these zeros here, this number is 52,000. If we take those zeros away, it becomes 52. They are placeholders. These 3 zeros are here to show magnitude, no more, no less, only magnitude. They are not measured zeros. So in this case, this number would have 2 significant figures. The trailing zeros do not count. Now, if we wanted to show that the number 52,000 was known to be exactly 52,000 all the way down to the ones position, we could do that. And the way in which we would do that is simply add a decimal point at the end. Remember, zeros at the end of a number with the decimal point do count. So we see there's a decimal point, and we have 3 zeros at the end of the number. Those zeros are considered to be significant. So this number would have 1, 2, plus the 3 zeros, 5 significant figures. Take a moment, write down the rule and the examples in your notes. Now, there are some cases where simply tacking on a decimal point at the end of the number will not give you the correct number of significant figures. Let's go back to our original example of 52,000. 52,000 as written has two significant figures. 52,000 written this way has five significant figures. But what if I wanted to express 52,000 with three significant figures? You might say, well, gosh, write 520 with a decimal point. That would be three significant figures, but it's the wrong magnitude. It's only 520. What we can do is use scientific notation as a way to keep the number as 52,000, yet express it to three sig figs. And if you'll take a look at the first example, that's what we see here. 5.20 has 1, 2, 3 sig figs, and written times 10 to the fourth gives it the magnitude of 52,000. Right there, that's 52,000 with 3 sig figs. We could also show 52,000 with 4 sig figs in the example we see here. 5.200 is 4 significant figures. Written to the fourth power, that becomes 52,000, or 10 to the fourth power, pardon me. So, take a second, make sure you have this written down, and do notice that when you're finding the number of significant figures in a number written in scientific notation, all you need to do is look at the initial number that leads it off. The 10 to the power is simply there to show magnitude. It is not a measured part of the number. So look at the beginning portion, we have 3 sig figs. Look at the beginning portion, we have 4 sig figs. Write that in your notes. You may notice from the web assign that we did earlier that there is another way to show scientific notation. And the way we do that is what we sometimes call e-notation. 5.20 times 10 to the fourth can also be shown as 5.20 E4. 5.200 times 10 to the fourth would be 5.200 E4. Again, just a new way to show it, still the same measurement, still the same number of significant figures. And last but not least, when we are doing labs, when we are working with numbers, there are times where we have exact numbers. An exact number is not a measurement. Therefore, there is not a certain number of measured digits. In fact, that number is exact. It is known to be that number to an infinite number of digits. That said, there would be an infinite number of significant figures in the exact number. And therefore, we don't count them. We simply don't care about these significant figures. So, some examples of exact numbers are what we call cardinal numbers or counting numbers. For example, a dozen eggs is exactly 12 eggs, no more, no less. It is not 12.1 eggs, 12.01 eggs. It is 12 point and then an infinite number of zeros after it because it is exactly 12. Other examples of exact amounts would be mathematical relationships, metric conversions. There are exactly 1,000 grams in a kilogram. Okay, the speed of light is exactly 299,792,428 meters per 1 second. It is exactly known to be that amount, no more, no less. So when we are using these exact numbers, we do not use them the significant figures of these numbers, rather. We do not use the number of significant figures in our calculations. We simply ignore them. So, after going through this quick tutorial and taking down the notes, if you're still alive, congratulations. Your head didn't even explode. Thanks for watching.